What's up? What's up? It's your man Jimmy Chan. So now we're talking about expected value. So the standard way to compute expected value is to multiply each possible outcome by its probability and then add these products. So one of the things that it doesn't say to you is that the possibilities here is not all wins. It may also be losses. So possibility by its the outcome by the probability, it could be wins, the possibility of winning, and the possibility of losing. Okay, so that's what expected values are, and that's how your insurance policies are determined. Weighs the risk over the benefits. A whole lot of different things. And then we also get to talk about the expected value to find the expected value of a game. Multiply the gain or the loss for each possible outcome and its probability, then add the products together. So I will always look at the gains and the losses, right? So let's take a look. So over here, it says the table shows claims and their probabilities for an insurance company. Use the table to calculate the expected value. So obviously, with insurance companies, it's really not about losses, right? Well, it is other people's losses, but the insurance company is paying the whole bill, well, almost the whole bill, right? Besides your deductible. So we need to figure out as an insurance company how much we're going to charge the customers. So in terms of expected value, then we know that's what we want to charge the customers as we go. So the amount of claim to the nearest $50,000. So here are their claims, and here's the probability of those claims happening. Okay, since this is a probability that's already set for you, I would tell you to go ahead and multiply these two numbers here straight across, right? So that this way you know what the possible outcomes are times the probability. So I'll have here, this is 0 times 0.65, and that's going to be just 0. Here, it's going to be 50,000 times the 0.24, and that's going to be 12,000. And then the 100,000 times the 0.07, and that's going to be 7,000. The 150,000 times 0.02, and that's going to be 3,000. 0.01, that should be 2,000. Let me double check. Yep, that's 2,000. And then 250,000 is going to be 2,500. Okay? So what I want to do now is I want to add all of these together. So if I add all these together, that should be my expected value. So 12,000 plus 7,000 plus, let's see, plus 3,000 plus 2,000 plus 2,500. That's going to give me $26,500. Okay, so that is my expected value. Okay. So as an insurance company, this is what I'm going to be expected to pay out for those claims every year, right? So if I'm their insurance company, if this is what I'm expected to pay out, that means, well, per vehicle, that means I want to charge this much of money for that, okay? All right, so there we go. Let's go to the next one. A construction company is planning to bid on a building contract. The bid cost the company $1,800. Okay, the probability that the bid is accepted is 1 out of 10. If the bid is accepted, the company will make $108,000 minus the cost of the bid, right? So I gotta find the expected value here. So, well, what are the possibilities that can happen? Well, they could win the bid, right? So there's a 1/10 of a chance that they can win the bid. And if they win the bid, what can they gain? Well, they can gain $108,000 minus the $1,800, the cost of the bid. Okay, because the bid costs $1,800, right? The bid typically costs money only because they want serious bidders. They want you to be putting some ante in there, right? But what could possibly happen? They could be turned down, right? Their bid could be not accepted. So if that's the case, I got to subtract what they can possibly lose. There's a 9/10 of a chance that they're going to lose this bid, and they would lose their $1,800, right? That's what's going to happen. What the heck happened there? That's interesting, right? They can lose their $1,800. So this is why I got to calculate. And when I calculate this, what I'm going to get is that when you put this in the calculator, you'll get an expected value of, wow, I don't know if it's the pen or if it's the user. Whoa. $9,000. Okay, so which is great because which means that I have it to gain, right? I have a chance to gain here. So this is actually something that's worthwhile to put that bid in, even if I only have 1/10 of a chance to win the bid. And why? Because the expected value is a positive 9,000. Okay, so it tells me that I have a better chance of getting it than losing that $1,800. All right, so last one. A game is played using one die. If the die is rolled and shows a 5, the player wins $20. If the die shows any number other than 5, the player wins nothing. If there is a charge of $4 to play a game, what is the game's expected value? Okay, so here, if I roll 5, so what's the chance of me rolling a 5? I have 1 out of 6 chances of rolling a 5, right? And I could win my $20, but I had to spend $4 per game. But I have a chance of losing, and the chance of losing is 5 out of 6 because if I roll anything besides a 5, I'll lose. And what am I losing? I'm not losing $20, but I am going to lose $4. Okay? And if I plug this into the calculator, I'm going to have an expected value of negative 0.67 cents. Okay, so in that case, is it really worth playing this game? And the answer is no, because and 0.67 cents, or I should say 67 cents doesn't seem like a big loss, But think about how many hands or how many rolls this person's going to get. In the long run, this person's going to lose more money than he's going to gain. Now, if this was positive 67 cents, then it's well worth while playing this game. Okay, so that's how they figure out how much to charge people, because they're going to make this calculation, and so that in the long run you will lose. You'll win some, you'll lose some, but most likely if you play in the long run you will lose. So hopefully that answers your question. If you have anything else, let me know. See ya. Bye.